I greet you wherever you are. My name is Biba Bright, and I am into bioinformatics and data science. We are on a series of packages in R, and today we are looking at the package called APE, APE, the APE package. It is used for building and visualizing trees in R. If you are conversant with phylogenetic analysis, if you are conversant with um, revolutionary tree building, then ancestry tracing, tracking, then you are good to go. This is the best place for you to be. But before we start, please do me a favor. Subscribe to this channel and turn on the notification bell. When I upload a new video, then you will be the first to know. And by subscribing, you are invariably supporting me. Please help me to reach 1,000 subscribers. Thank you very much. All right, now let's go. So I'm going to pull up my arrow. So I think as we change the orientation, this is quite better. All right, so this is the APE package, and what I just put it around here. So if you are joining my tutorials for the first time, if we want to install the APE package, this is how we install it. Install.packages, and then you put the name of the package inside here. A package is simply what is a tool that is made up of series of functions. So every package comes with a lot of functions. All right, so let's look at, now I have already installed it, but you will use this particular line 480. This is how to install a package. Then to load it, when you install it, it's on your C drive, but it's not on the R environment. To load it, then you use the library and then run this. I'm going to run that, and then at the moment it is loaded. If you want more information about the package, let's say, so like more, let's say, info about the, let's say, the APE package, then you are good to go. Then you simply use either a question mark or two question marks before the name of the package here. And then when you run that, then it's going to build up, but you require an internet, and I have internet at the moment. So it's going to take a little while, but it will bring out the information that you need about the package, which is here. So now, checking for functions in the package. I mean, it's important to know what are some of the functions which are found within the package. So how do we check for that? I think it's not only the this particular package, but any other package at all you want to know the functions which are there. After you have library the package, you need to library the package first, which means you need to load the package into your R environment, and you use this particular lsf.struct, and then you put into bracket package, then a colon, and then the package, what that particular package name, and then when you run that, it will bring out all the. So you see, when I do that, it prints out all the functions which have been written in that particular package. So these are all the functions that if you want to know about the package, then yeah, I mean, we can't exhaust all of them. We might use some, we may not be able to use all of them. And so let me try again with a different package and see if that is going to work. And so what I'm going to do, I'm just going to, I don't know if that package is loaded, and this is what I mean. So I've copied it. I'm just going to come here, then paste it. And then in this particular case, I'm changing this particular package into what I call the dplyr. That was a package we learned before here. I'm not too sure if the dplyr package is loaded. So I'm going to click on packages. I'm going to come here and type dplyr. So dplyr package is not loaded, so you need to load it. This is another way of loading a package. You can tick on this particular box, and dplyr is loaded. So now let's look at what are some of the functions which are found in dplyr. So we use the same, and so you can see when you run that particular line, several functions under dplyr are all there. So that is the code we use to be able to check. So it's lsf.struct, just like the way we look at a structure, and then we are good to go. Now, how do we build a tree? How do we build a tree? Because we have already loaded the package, the APE package, and I said the APE package is used for building trees. Now let's look at the basic way of building a tree. So it has a function. I should have shown that particular function called R3. So R3 is a function under the APE package. So when we run the R3 and then we indicate the number of nodes, then we are good to go. So here I am building a tree of 20 nodes. So that's why I say n is equal to 20. Another one, n is equal to 50, and then n is equal to 30. And so I'm just going to highlight all of them. Then I'll run that. So now, if we have done that, we package each of the trees we have built into this is the first tree. And so now, if we run that particular one, we can see how the tree has been built. So it's a phylogenetic tree with 20 tips. So that's why I was saying, I think I was making a mistake. Not the nodes are, it's not a nodes, it's 19 internal nodes and then 20 tips. It's understandable. And then you also have the tips, and then you have the root, and the root included. So this is the tree we have just built using this particular function. So what it means is that once you are able to give the tips, then automatically it will build the rest of the whatsoever that you want for you. It will build the rest of the node, the internal node, and then the rest for you. So now let's assume that I have, let's say, I have another tree here, and I'm going to call that tree 5, or let me call that tree A. And so here, I'm just going to do that. And then I will say my R3, or I think my R3 should be this way. I was expecting it to come as a function. So I have my R3, yeah. So it comes like this. I'm going to say that my n is equal to, instead of giving it, let's say, instead of giving it, let's say 20 or something like that, I'm going to say, I'm going to use something called latest. It's going to be this capital letters. And then under the capital letters, what am I going to do? I'm going to say I want from 1 all the way to 20. So let's try and see if we can build a tree. Okay, I think that's error. If n is less than 1, stop. A tree must have at least 1 tip. Okay, so I was trying to see whether I could use this to be able to build a tree, so that I will assign just about 20 of this, 20 of A, B, C, D up to that into n, and then build with it. But remember, this is characters, so it's unable to do the the computation. That's why. So I'll take this particular line out. But in data science, it's always good to explore. And that's why when you try one, it works, you explore for the other one. And then that is how I learn alongside. Now, after I have built the trees, I've looked at one of them, which is here. Now, the next thing is, how do we visualize the tree? It's simple. We can use plot. So you bring the tree that you have already built, which is here. And then you simply indicate your edge width. So that's the width of the edges. So that one, you can choose any number at all. And so when I do that, it will simply build this small tree for me. And as you can see, the tree is there. Now, we could also plot the tree 2, and then you can see how tree 2 looks like. And then the tree 4 is also there. So this is how they all look like. Yeah, quite beautifully. So now, final arguments of the tree. Now, after you have built the tree, I mean, even though when I run the tree, you will see all the information like the phylogenetic tree with 20 tips, 19 internal nodes, tip levels, and whatsoever. You're going to see that. But there are other information that is hidden within the tree that we can. So how do we do that? We use the structure function, and then we put the tree inside. Then we run it. So it tells us that we have the edge, we have the tip level, we have the end node, we have the edge length, and so these are individual functions or things that have been built with the tree, which we could have also added them. We have attribute is equal to class, and we have another attribute here, which is order, and then it is class wise. I think it's like kind of like clockwise. So that's how the tree is looking like. And then we can also check for the edge. So we've seen that the edge is here. But what does the edge mean? So what these functions have done here, the tree function has done, the R tree function have done is to simply generate or to automatically generate the matrix. You see? But if we want to print the exact matrix, that led to, we only give the tips, and then the R tree will automatically generate the rest of the information. So to get the rest of the information that it backward computed, then we simply run the edge. So when we pick out the edge alone and then we run it, you see that it's going to give us a matrix. And then that's the matrix around here. So it's kind of like two columns, and then how many rows, and then this number of rows that we can see around here. So that's how it automatically build the, and then we have our matrix sitting around here. So that is the background computation that actually worked, if you want to know. Now, there are instances you might not be interested in plotting the entire tree. I think I'm jumping the gun. So the next thing, we could also build a tree by using read.tree. It's also a function. And then here we now have the text. I think this is what I was trying to do earlier. So we are using this particular argument called text, and then we assign the whole of this into that particular argument. And then we use the read.tree function to build it. So when we do that, the tree 4 has been built. Now let's look at what is inside tree 4. And then we might possibly see that it's also the same thing with your phylogenetic tree, 5 tips. And so if it is 5 tips, let's look at what it is. A, G, C, H, and K. They are actually 5. And that's what happens there. So now after we have built it, then the next thing is we can also use the plot. But in this particular instance, we've decided to add other argument. So this is the data of the tree, and then the argument we are taking the cladogram, and then the edge width, then we can simply add this. As usual, if you are new to R, when you are doing a function, or if you are using a function, you just come and click here. Sometimes you are likely to see, or let me click inside here. So you will see the function argument, they are all here. And then that's how to be able to. And so you can see this how it looks like when we visualize it. So this is cladogram. Cladogram. It's kind of like a what a phylotomy or phylotomies. I will explain that later. So we could have also done that for the first tree that we built. And then this is how the cladogram would have looked like. And so that's just the difference between the ordinary tree. But this is kind of like unrooted tree. You can't see the root. You don't know the kind of root. We can only assume that this is the root, the origin, then in that order. So, of course, we could also look at the tree.edge the same way. We can see the matrix, the computation that went into it, even though we use the alphabet, but because we use a particular argument and we use this function called read.tree, it has converted all of these characters and then computed them out for this particular matrix we see down here. So it means when we take this matrix, we can rebuild this tree the same way like we have it here. It's already matrix, so it's easy to build a tree with a matrix data. Now, let's see, how do we plot a half tree? It's not all the time that you plot the entire tree. So I'm going to plot a half tree. Now, this is the full tree of tree 4 that we have already built, which is here. Now let's plot a half tree and let's see. So we indicate the plot function, indicate the data, which is the tree 4. And now we say weight is equal to false. And then let's see how it works. So you notice that when we are plotting the half tree, you see how it looks like. And then that's how it looks like. And so we are good to go. So if you are plotting a half tree, the weight we normally would reduce it into false. I don't know if I put it through. I haven't tried it through. And if I put through there, what is going to happen? Let me run that and see. Yep. What is it? I've given a warning. So the plot warning doesn't mean that it is wrong, but maybe the best practice that I did not follow. Okay. So the next thing is finding the note levels, or the note levels of figures. So I'm going to plot tree 4 again. And this time around, I'm giving some argument. All this argument can be taken. And so the edge width, we're putting at 2 level dot offset. And then that is it. So let's plot it first, and then we look at what that means. So you see, that's a cloudogram because we indicated the type as cloudogram. And then we can add the node labels. The node labels, when we put here, it means a function, which means within the function, we could also add some argument. When you put it here, you see whatever that we have on top here. It tells us what the argument will look like. But here, because we are not putting anything there, it will take the default. So here, when we are adding the node, all the node labels. So here, this is the node, the node, the node, the node. So it will give them labels automatic because we haven't given any argument, we haven't specified the kind of labels we want it to be. So it gives it what is it, its own labels. So what about the tips? These are the tips. The alphabets are the tips. And so what level do we want? Tip levels. Because we haven't given anything, it will automatically give it figures or numbers. And so as we can see, 1 all the way up to this. So up to 5, then it begins from 6, 7, 8, and then 9. So that's how it works. Obviously, 6 and 5 is an outgroup. I will explain phylogenetic tree somehow later. Now, writing phylogenetic tree. Now, sometimes you can build your phylogenetic tree here, but you may not want to use R to visualize it. So you may want to, let's say, visualize it in another, maybe in a different, with a different tool. Now, we had already built this particular tree called tree. And so how do we write it? We say write.tree. So we indicate the tree, just like the way we write a CSV file or a table or an Excel file into, we write it. It means we are copying it out. We are not importing it. So we are taking this data out of our environment into our local computer. And then maybe a different tool can be used. So I want to do that. So I'll say write.tree. Then I put the tree I've already built, which is here. And then I'm saying that when I go to my other parts, onto my local computer, I will see tree.tre. The file extension, you cannot change it, but you can change whatever that is here, and then that is good to go. So if I can put here 1, but this one, the file extension will have to remain the same. So when I do that, if I go to my local computer now, and so which working directory am I? So I need to check my working directory. So I'm going to say get working directory, get my working directory. I think that's a minute. So I'm going to say get my working directory, and then I'll run that. So I'm actually working on my desktop. So I'm going to go to my desktop here. And then when I come to my desktop, I'm expecting to see 3111 something something. Let's go. Yeah, so you can see it here, 3111 something something, which is over there. So now I can now use this file into any online tool to visualize it. Now let me get back to R and show you something. So let's assume that I want to build a tree of 100 nodes. All right. So I'm going to say 300 3.100, and then so I'm just going to use how we build the R tree. If you remember, we just say R tree. So R tree like this, and then we are good to go. So we simply come and then we indicate the node, our n, and say our n is equal to 100. And then we can say it's a rooted. If we say rooted, we should say true. Tip level, we can add our tip levels, we can add whatsoever. So I'm going to say my n is equal to 100, and then rooted. So rooted is equal to true. And then as we leave it at this point, maybe I could add the other things that I wanted, but I'm going to leave the tree at this particular point and run it. So the tree is there. Now, let's assume that I want to take the tree outside of where I am and go and visualize it in another environment. So what I'm simply going to do, I'm going to say write dot tree. Because I've already loaded the APE package, it allows me to be able to do that. And so I have to put the 3.100. The 3.100 is the file I am writing to where I put comma, and then I have to put in the inverted commas. So I'm going to just repeat the same name. I'm going to say 3. This time I'm going to call 3_100 dot. And I said the file extension cannot change. It's TRE. Then you leave it that way. Now, when I write it, you notice that it has this particular tree has gone to my desktop. So now, if I go to my desktop at the moment, sorry, if I go to my desktop now, you can see 3_100. So assuming I was on this particular, so I could use a tool like this, iTool. Let's, my internet is not too strong. If the iTool opens, then I can simply come here, choose my file. You get it? Then I simply go to my desktop. So it's like it appears I'm already on my desktop. So this is the tree, 3.100, and it's a rooted tree. And so I have uploaded it here. So let me do upload. So I can build a tree from this particular environment. That you see that the tree has been built. And so you can see how what they look like. So I can now use this part to be able to adjust whatsoever. I could adjust. So I could come here. So you can see how what the tree would look like. Maybe you could just change the colors a little bit, and then I choose that particular color. Maybe the tips I could have maybe chosen maybe red color. I'm not good at colors. And then this particular point, I could choose. Let me choose blue again, and that is it. So if we wanted, so we could just make it look fine. And then I could just, so I can do all sorts of alteration here. And you see that the tree has been built, but it's circular. So if I wanted to reduce, I could reduce it this way to make it a little bit of, and then change it a little bit here. And then I think it's all right now. So I'll come and simply increase the font size around here. And so I'm just going to drag this a little bit down here. And because it's a rooted tree, so my tree is ready. So you can see how it looks like. Then let me fold this up and you see how the tree is looking like. And so this is the reason why we write it to the tree. You could write it and go and visualize it in another place. So I just build a tree and then I come to visualize it around here. So now let's get back to R. That's what I wanted to that's the point I wanted to make. Now let me load in another tool, which we call the file tools. So I've already installed the file tools. So it's loaded. What the file tool does is also work in collaboration with the APE, but it allows you to be able to write. You can also write the tools. You can also write, the tree as an Excel tree or whatsoever. But what I want to use it for is a little bit different. So now let's simulate trees or plot them, extract the class, and then drop tips from the tree. How do we do that? So we want to simulate a tree. And we want to see how we can do all this. We first of all have to simulate the tree. We have to plot the tree, and then we extract the class, and then we drop the tips from the tree. And let's see how that works. So I'm going to set my seed to this, and then this is how to simulate the tree. So we are using the PB tree. It's a function, and then we say B is equals to 1, G is equals to 0.2, and N is 40. So the nodes are going to be 40. And so the tree has been built. Now, if we do this, we can see the tree around here, which is, we can see the phylogenetic tree. We can see it is a rooted tree, include branches. So now, when we finished, we could have written this too, but this time around, we can just plot it here. But because we are now using the file tool, we use the plot.tree, and then we call that tree, right? So I think this should have been my tree 6. So let me put that tree 6 because it will write over the other tree. So I'll run that line again. And so I will say stopping what criterion is 40 extant species in this case. So Uh, so I'm just going to run that again. And so now look at how the tree looks like. It's quite, so you see how the tree looks like. So now let's look at how to be able to extract all that we have spoken about. So now when we come here, we could have added the node level. That by now we should know how the node levels have been added. So you can see all the node levels are added now. I think I should have reduced the size of the node levels. You simply put an argument in the, you see the node levels are too, the size are too big. I don't know if I have size here so that I could have, I'm trying to see if the function can, is there size? I think I could have used it, the node, then the adjustment is here, 0.5, 0.5, I could reduce to 0.1, 0.1, but let's leave that. Now, extracting the clad, like we are going to extract the clad from the node. And so here we say extract. This is the function that we can extract. Okay, we are extracting. So we are going to extract the clad. The clad is like a cluster. So we are going to, and so we simply say tree 6, and then we are extracting it using this particular figure, right? So, and now when we plot it, what do we get? We get something like this. So let me pull this a little bit away, and let's come here and look at something. So look at how the tree looks like. And so this is the one we have extracted. Look at the original tree. The original tree was like this. You see? So you can see that the original tree has more nodes. It has more tips as compared to the one we just plotted, which is having a lesser node. So we have extracted part of it. So what we have extracted a particular cluster, and then that is it. So that's, now let's drop the tips. How do we drop the tips? How do we drop the tips? So we simply say like D tips means drop tips. And so we say sample. So we use the function called sample, just like the way we do ordinary sample. So we are sampling from tree 6. And then we use the dollar. So when we use tree 6 and we use the dollar, then we simply say the tips dot label, and then we add this figure to it. So when we do that, now, so what do? We now say we drop the tips. So drop dot tip is a function. Then we go into the tree, which is tree 6, and then we have already picked out all the tips and we packed it into this. And so now when we say drop the tips and we go into that particular tree, then we use that variable and say that's what we want to drop. So we are dropping this variable, which was originally part of this, from the tree, and we pack the entire data into this. That's exactly what we have done here. So if you run that, and then we now plot the tree, you won't see the tips. And so we plot the tree. Okay, let me see. I don't know whether I ran this first. So again, then let's plot the DT. Well, I can see the tips are there, but I wanted to drop the tree while they wanted the tips. So that's how we are, what do I mean? We drop the tips. So what about dropping all tips that go extinct? Here, we're dropping just 10 of them. Here, let's drop all the tips. So we say, and we use a function called fancy tree. So fancy tree, then we go into the tree 6, and then we say type drop tip. Remember, drop tip is a function. So we are now using it as an argument here. And so we say the tip is equal to get extinct. Then we indicate tree 6 over there. And then we are simply just, this one just has the size. And then when we run that, we are good to go. And so check something. We're going to print. So this would allow us to know. So you can see some kind of lines. I'm coming here. So you can see some kind of dotted lines which have been indicated in some parts of the tree. And that's what I was saying, we're trying to explain. Now, I think the video is getting too long. I'll leave it here, and tomorrow I'll bring out another video, and that will be on binary and polytomous. What are polytomous trees? So we have a tree that you can have more than 5 branches coming from one node, or more than 2 branches coming from one node. We call them polytomous or polytomy in phylogenetic analysis. And then the outgroup. So we'll be looking at binary and polytomous trees. What is it tomorrow? So thank you, and I hope you've enjoyed how to be able to use the APE or the APE package in R for tree building and for tree analysis, or for tree plotting, extracting part of the tree, picking just a clade or a cluster out of the tree, then plotting half of the tree, and or visualizing half of the tree, and then other analysis that you can look at. You can just pause the video, look at the whatever that is there, and then you try to put your hands on deck. One of the ways to learn data science is try to type. Learn how to type. Don't just copy the code and then drop it. No, that way it won't allow you to be able to learn. All right, thank you. And please do me a favor by subscribing to this channel. Right, so that's your video of today. And thanks very much for being around. Please subscribe to my channel and help me. Let me get to 1,000 subscribers. Yeah. Bye-bye.